Communication Technology presents educational satellite television programs.
Hello, teacher. Hello, students. Welcome to today's lesson about polysaccharides. You have learned about monosaccharides and disaccharides in the previous lesson. Today, we will learn about polysaccharides. We will learn to describe them and to recognize the structures of starch and cellulose. We will also learn the differences between starch, cellulose, and glycogen. This will be a very interesting lesson. Students, let us begin by defining the term polysaccharide. Polysaccharides are condensation polymers. It consists of a large number of monosaccharide units that have been bonded together by glycosidic bonds. The three most important polysaccharides are all made of glucose. They are cellulose, starch, and glycogen. Cellulose is the most abundant polysaccharide. Structurally, it is a linear glucose polymer. The individual units of glucose are linked by beta-1,4 glycosidic bonds, as we can see here. Cellulose does not give humans any nutrition. This is because humans do not have the enzyme called cellulase, which can hydrolyze the bonds and produce free glucose. Herbivores, like cows, on the other hand, do have cellulase in their systems. Therefore, unlike us, they can produce free glucose from cellulose. This is why cows are able to live on grass. It is a source of nutrition for them that it could never be for us. It is time for our first activity, students. Please select a partner. Thinking about what we have learned so far, what kingdom in nature is made largely from cellulose? How many members of that kingdom can you name? Take a few minutes to list as many as you can.
Students, let's get ready. Begin. Time's up. Let's get back to our lesson.
Welcome back, students. I am confident that you had no trouble in answering this question. The kingdom in nature that is made largely from cellulose is the kingdom plantae, or the plant kingdom. This includes grasses, trees, flowers, and algae. All of these are plants. Therefore, all of these have cell walls that are largely made of cellulose. You may have listed many different plants as part of your answer. Every plant you have named is correct. Great job. As you can see, cellulose is a polysaccharide that is very common in nature. In fact, it is the most common organic compound on Earth. Another polysaccharide is starch. Starch is used for energy storage in plants. If excess glucose enters a plant cell, it is converted into starch and stored for later use. Let us study the two principal components of starch. They are called amylose and amylopectin. Amylose makes up 20 to 25% of the structure of starch. It is a linear polymer made up of D-glucose units and linked with alpha-1,4 glycosidic bonds. Its structure is tightly packed, so it is resistant to digestion and insoluble in water. Amylopectin is a bit different. It is a soluble polysaccharide, and it is highly branched. It makes up 75 to 80% of starch. Like amylose, it is largely made of alpha-1,4 glycosidic bonds. Unlike amylose, though, it branches every 25 to 30 units at alpha-1,6 linkages. Because of this, amylopectin has a much larger molecular mass than amylose. Starch is the most common carbohydrate in the human diet and is contained in many staple foods. Students, let us do our second activity. How many foods can you think of that contain starch? With the same partner, please list as many as you can.
Students, let's get ready. Begin. Time's up! Let's get back to our lesson.
Hello again, students. Some correct answers include rice, wheat, and maize. Potatoes and cassava also contain a great deal of starch, as do beans, peas, and malanga. If you listed any cereals, root vegetables, nuts, or legumes, you got the correct answer. These are all great sources of starch. Now, let us study the third main polysaccharide. It is called glycogen. It is known as the animal starch because it stores energy in animals like starch does in plants. In humans, glycogen is stored in red blood cells, liver cells, and muscle cells. It forms an energy reserve that can be quickly mobilized to meet a sudden need for glucose. Glycogen has a similar structure to amylopectin. It is joined by alpha-1,4 and alpha-1,6 glycosidic bonds. However, glycogen is about 3 times more highly branched than amylopectin. For our last activity, students, I would like you to form groups of 3 or 4. We have discussed the 3 main polysaccharides. What are the major differences between them? Please go ahead and discuss this question now.
Students, let's get ready. Begin. Time's up. Let's get back to our lesson.
Good to see you again, students. There are many differences between the polysaccharides. Cellulose uses beta-1,4 glycosidic bonds, whereas starch and glycogen use alpha-1,4. Cellulose and starch are both found in plants, whereas glycogen is found in animals. Starch is digestible by humans, whereas cellulose is not. There are many other correct answers as well. Teacher, after the lesson, please continue this fascinating discussion about polysaccharides. That is all for today. We have learned about the 3 main polysaccharides. I hope that you enjoyed the discussion. Until next time, thank you, teacher. Thank you, students.